and we're traveling for, say, 2 hours, then how far have we traveled after those 2 hours? Well, we've traveled 100 kilometers, right? That's the basic idea of distance, rate, and time problems. We already know how to do that. We already know that concept in general, right? Formalizing that up with mathematics, we have the following. Distance is equal to rate times time, right? 100 kilometers is equal to 50 times 2, right? That's where we got that from. All right, we'll also kind of abbreviate it to just D equals RT, right? Distance is equal to rate times time, right? All right, so let's look at an example. All right, two cars start at the same time from the same point, and they travel in opposite directions. Their rates are 49 and 57 kilometers per hour, respectively. How long will it take for them to be 265 kilometers apart? All right, so first off, we need to make sure we understand what is happening, right? We've got a point, right, and we have one car going off in this direction and one car going off in this direction from our point, right? Because they're going in opposite directions, right? Let's say this one's going 49 kilometers per hour, and let's say this one's going 57 kilometers per hour. Just so we have a picture of what is really happening, right? Okay, well, we know that distance is equal to rate times time, right? So we know the rate for each one of these. We know the distance we want them to be, right, which is apart. We know the distance we want them to be apart, which is 265 kilometers. Right, so what we're looking for is time. How long will it take for them to be 265 kilometers apart? So we're looking for t, right? So this part right here, if you're going 49 kilometers per hour, then the distance, d, is equal to 49t. Everybody with me on that? Because distance is equal to rate times time. Well, we don't know the time yet, right? So the distance is just 49 times whatever the time would be. That would be that distance. This distance over here is 57t. Everybody see that? Okay, because it's 57 kilometers an hour, and again, we don't know how long it is, but this distance over here to the right would be 57t. Now, we know that after so many hours, whatever it is, we want them to be 265 kilometers apart. So that means this distance to the left, the d equals 49t, and this distance, 57t, those two things have to add up to 265 kilometers. So our equation is 49t plus 57t is equal to 265, right? Distance of the first car going out to the left plus the distance traveled by the second car going out to the right, those two distances added up have to be 265, and that's the equation that we have to solve for t. We get 106t equals 265, divide both sides by 106, and we get t is 2.5 hours. So, after they travel for 2.5 hours, they will be 265 kilometers apart. All right, that's kind of the idea. Right? Sometimes it helps to draw a picture so you can kind of see what's going on. But then it all boils down to distance is equal to rate times time. Now, there are many variations of distance, rate, and time problems. I'm more concerned that you understand the concept. Distance equals rate times time. And then it boils down to just trying to determine which letter it is you're trying to solve for. In this case, it was t, time. So then we needed something for distance, and we needed something for rate. Sometimes you'll be looking for rate, sometimes you'll be looking for distance. Doesn't really matter. The concept stays the same, but sometimes you need to draw a picture in order to help you figure out what the equation would be. All right, I'm going to leave it at that, and just let you guys work on some problems and contemplate how to apply this distance equals rate times time idea to some of those problems. All right, that's it. Study well. Please let me know if you have any questions.